This meeting is being recorded.
Okay. So now I'm going to open an Excel file and I'm going to take the contents into Minitab. So once you click on the Excel sheet, whatever the contents that you have in that will be copied to your Minitab folder. You can see this, right?
Yes.
You can see the results here. Whatever I had there that I have copied to this particular Minitab file. So I can save this project. I'm going to save this project as, I'm going to give a name. West Pharma Minitab. And I'm going to save it in desktop. Okay. Fine. You can even save the worksheet. You have different worksheets here. You can save the worksheets separately also. See, I'm saving that worksheet as Minitab worksheet. I can save it as in Excel format also. So once I save it in Excel format, I can retrieve the Excel format also. Those contents could also be retrieved. Now I'm moving to the next, edit. This is very common as you see in an Excel. Undo options, redo options, clear cells, clear cells. So it just clears it. Undo option, delete cells. So all those options you would have already used all these options in Excel, right?
Yes.
Same options you have here also. Now I'm getting into the data subset. What do you mean by a subset? See, I'm creating some kind of, I want only certain data from this, then I can go for subsets. So let me work on that. Here I'm going to do subset for sales, okay? So the column that I'm going to do subsets is sales. So for first, what I have to do, I have to select, use rows that match a condition, include rows that match a condition, and I have to select the column. And here I'm going for a particular condition that is greater than. I'm selecting only values, sales, if that is greater than some value, I'm going to select that and I'm going to add that in a new worksheet. Okay. So I'm selecting sales. The condition that I'm giving here is whatever that is greater than 250. I want to select and I want to take it to a new worksheet. So new subset. Okay, I'm giving the worksheet name is new subset, and I'm taking it here. So you can see a new worksheet is created, right? The name is new subset, and it has values only that is more than 250. Okay. So whatever condition that you give, whether it is greater than or lesser than, based on that, you can create a subset. Okay. Split the worksheet. Split. Let me go back to that. I want to split this worksheet based on ad agency. So I have just given it here. See, when you select ad agency, it gives a result only specific to that ad agency. So here all alphas will be there, only alpha. There are two types of ad agencies, alpha and omega. So all omega will come under one sheet and all alpha will come under the other sheet. So you are splitting the worksheet based on one particular category. So initially I had all in the same, but now I'm having it in two separate worksheets. One is specifically for alpha, the other one is specifically for omega. Okay. Now coming to stack worksheets, stack. So I can stack the worksheets one over the other. For example, here I'm going to stack alpha with omega, and I'm going to store it in stack. So both alpha and omega, I'm going to get it in the same worksheet. So stack is, you're going to get the both alpha and omega, you're getting in the same. Here you can see that now I have got both these data in the same worksheet. Okay. So two different worksheets, you can stack one over the other. So that is what you're doing here in the stack. Next is merge. Merge. So merge, you have two options. One is merge values, merge with values. I want to merge alpha. Let me. I want to merge this alpha with omega. So I'm going to data. So, and I'm merging this worksheet. So this alpha should be merged with omega. I want to merge with omega. So I'm selecting omega and I'm mentioning the output name. The worksheet name is new merge worksheet. I'm clicking OK. So I got new merge worksheet where I have alpha and omega data together here. So this is the sales values, this is a advertisement cost, and this is a alpha. That is agency, ad agency. This is the sales value, and this is the advertisement cost, and this is the omega. So I'm getting both alpha and omega merged into one sheet. So that is what we have seen here. Now I want to match the same thing, but match side by side. Let me show you how to match it side by side. So go to data, go to merge sheets, go to side by side. I want to merge alpha with omega. Okay. And the worksheet name I'm giving merge alpha and omega. Okay. So here I get both these results in the same sheet. I have merged two different worksheets in the one worksheet. So that is merge worksheets. Then copy columns to columns. I can copy one column to another column or other worksheet. So here I'm copying this column sales. I'm taking here to a new worksheet, new sales. I'm naming it as new sales. So I'm taking that data to a new worksheet, and that is named as sales. Okay. So the worksheet name is new sales, and I have copied it to an other column in a new worksheet. Unstack columns. Unstack. Let me show you how to unstack. Unstack the data in sales using the subscription ad agency, and I want to take it to a new worksheet. Unstack new. See what we had in the data. We had the sales data of both alpha agency and omega agency in the same column. I'll just show you the data. So we had both in the same column, but now we are having it in a different columns. Sales is of alpha is in a different column, omega in a different column. Here, you used to have both the sales in the same column. Okay. So this is unstacking the columns. Similarly, you can stack the columns. So stack.
We can't hear you.
Am I audible?
Yes,
Am I
very
audible?
much. Yes, yes, very much.
Okay, okay. To stack columns, I'm just taking.
Sir, voice is not audible.
Yeah, I didn't speak anything.
Mohan is not explaining. He's just
I'm
taking the
just
slide.
working on one.
Okay, okay.
Okay. So what I have done is I have taken the sales of branch 1 and branch 2 and I have stacked in the same column now. Okay. So that is what we have done. So I'll show you the data. Stacking means making it into the same column, and unstack means you take it to different columns. So you have branch 1 and branch 2 data. So both I have added it into the same column. Okay. So that is what we have done here. Now transpose columns, transpose. When it comes to transpose, sales, I'm transposing it to a other worksheet. The worksheet name is transport. I'm transposing the sales data into this particular worksheet. So I have transposed the sales data down here. Okay.
So this is just like a Excel only, like a transpose. So horizontal to
Yeah.
vertical to horizontal. Okay.
Mostly same only. Mostly same. What I am showing you now is all basics in this. Then we can get into, once we get into stat and graph, we'll be using all these things.
Yeah, please go through one by one. We need a basics. Yes, we need, please.
So
Now
which
stop.
version you are using?
I'm using 19.
19. Okay. So
19.
the display looks a little different. That's what I'm asking.
Oh, okay. I have 14, I have 17, I have 19. Since you are using 18, I'm going for 19.
Yeah.
Okay. If you generally we do trainings with 14.
Okay.
Because that has better options and this that has a report pad, and there are certain advantages in the latest versions. There are certain advantages in the older versions also. Now I'm going for sort. Sort. I'm taking sales. I want to sort in increasing order. I want to sort specific column, that is space sales. I'm selecting. Let me this could be much useful. I'm specifically selecting sales. And specifically for that. So I have sorted out in increasing order here. Okay. So this gives a sorted sales in increasing order. Then if you want to select decreasing, you can get decreasing also. You can get decreasing order also there. In conditional formatting, how to highlight cells. So let me delete this cell. Okay, I want to highlight this cell where there is no data. So let me see how to do that. Missing observations. Missing observations, I'm going to sales. I want to show the missing observations as red color. So I'm clicking OK. You can see the missing cell is changed to red color. Can you see that?
Yeah.
Yes.
Yes.
Okay, so now let's see some more conditional formatting. I want to see greater than. In the column sales, I want to see greater than 220. I want to represent it in yellow color. So I'm clicking OK. You can see whatever that is more than 220, it's represented in yellow color. Yes. Now, similarly, lesser than sales, less than 220. I want to represent in green color. It's showing in green color. Okay. Now, between sorry, 220 to 250. If you want to select custom, then you can go for customs. And I can go for whatever color I want. And I can click OK on that. So this is between 220 and 250. Okay. Next, conditional formatting. I'll go for text. For text, let me show you another data. I'll copy it into that. So I'll go for data, I go for conditional formatting, text contains alpha as red. Okay, so you can even use it for text also. Then highest values, lowest values. Let's go to this. highest values. I'm selecting sales. I want to show the highest 10 values, the format cells that rank in the highest. And I want to give a custom color for that. I'm selecting this color. I'm clicking OK. So you can see that the highest 10 values, the 10 colors are changed. Okay. Now, coming to the next, highest percentage. So I can select sales, what percentage I want. I can select that 10 or 20, highest 20%. Okay, highest 20%. I want to go for custom. I'm selecting the color. I'm taking this color. I'm clicking on OK and OK. So you see the highest 20% is displayed here. Last 20%, maximum 20% in sales. Okay. Now coming to recoding. So recoding is changing your data. Okay. Changing your data. Now I want to change my data. This is text data. See, when you see text data, you can see T there. Can you see T? That indicates it is text data. Okay. If T is, sometimes when you just type some numbers like this, and by mistake you have mentioned any full stop or anything like that, it will say all these indications it will give. Okay. So if you have made any mistakes in that, it will give an indication. So it will automatically, it will take. So previously in the older versions, what will be there? No, we when we have numbers and when we type a text, it will accept that. But now what is happening? It will give you an indication so that you don't make such mistakes. Previously, we used to make a lot of mistakes. When we put 3, we'll put a dot for that, or we'll put some kind of letters in that column so that while we are analyzing, we'll make some mistakes. But now that possibility is absolutely not there, since it is giving a indication that it is not right. So now what I'm going to do is I'm going to convert this text data into numeric data. So that is recoding. I'm selecting add agency. I'm recoding it. So I'm going to recode alpha as 1 and omega as 2. And you can see the star. The star is a missing value. Let me remove that missing value. You have a star after that. So these are the missing datas. See, the problem is when you actually open an Excel, existing Excel, one column is longer, another column is shorter, it will display the data as missing in that. So in such situations, we can copy and paste the data as we generally do it in an Excel. Okay. Now I'm going to recoding. I'm going to change it to numeric. I'm selecting add agency, which is now a text data. The methodology is I want to recode it to individual values. Now you can see alpha and omega is there. I'm going to save it in the same worksheet at the end of the current worksheet. I'm clicking OK. You can see all alpha is converted to 1 and all omega is converted to 2. And you can see this is converted to a numeric data. So as I have already informed you, you can use only certain tools and techniques when you use numeric data, and you can use certain tools and techniques when you use text data, discrete data. Okay, so that's a purpose. If you want to do certain other analysis, you can convert that like this. You can give a coding and you can convert that into a numeric data. Now you can again You can convert that into text. If you want to convert this into text, you can do that. So I want to convert all 1 into alpha and all 2 to omega. So that is what I have done here. I have recoded it. Okay. So you can convert either a text to numeric or a numeric to text. Change data type. Add agency, you want to change it to numeric. It cannot be converted to numeric because in such situations you have to recode rather than changing the data type. So that may not work here. Change data type. Let me copy it again. Okay. So change data type. Add agency. This is this one. Coming to changing to text. So I am changing this sales to percentage. Okay. So whatever data that you want to change, you can change it here. Most of the situations, if you want to convert into decimals, then you can convert. So that is what we have done it here. Okay. So what is the format you want? You can create. If you want to convert a text into numeric or numeric into text, you need to go for recoding option. Okay. I am going to another basic, that is calculator. So calculator, this is something that is very useful in some situations. You can use the calculator for calculating mean, median, or standard deviation, like that. So here in store result in variable, I am typing C8. I want this result to be stored in C8. And what I want to do is, I'm going to statistics. I want a sum of the you can see sum in brackets, you'll get a number. You need to select the column you want to do and then click OK. Okay. So now you can see here in C8, I got the sum of sales. So the total sales for all those months is 8,239. So I'm getting the, using the calculator, I'm getting it here. Then let me go for mean. Sorry. So similarly, I'm storing it in C8 and I have to calculate mean average of sales. Average of sales. I'm clicking OK. So this is average of sales, 343.292. Okay. Some more functions, minimum, maximum. Let us go for minimum. Minimum in sales. Minimum is 202. Then I'll go for this percentile. Percentile, it's very useful. In sales, I have to see, I have to calculate percentile in sales for a probability of, for example, 0.25. Any idea what is probability? Probability?
Chances.
Chances. Okay. So number of expected values divided by number of possible values. So when you throw a dice, what are the total possible possibilities you can get? 6, right? If I have to get 5 from that, what is my probability is 1 by 6. Okay. So probability is total observed values divided by, sorry, expected values divided by the possible values, possible chances. So here I am selecting sales. I'm going to calculate percentile for sales. And what is the probability I have selected? 0.25, that is 25%. Okay. If I select OK, I'll get 292.25. So what does it indicate is 25% of your sales is below this value of 292.25. Okay. So percentile is, it indicates 25%. I have what probability I have selected in my example is 25. Sorry. What I have selected is 25. If you put 75 in sales, let me see the result. So 75% of your sales is less than 408.25. Okay. So percentile gives you the percentage below which your data exists. So it could be, if you put 0.20, 20%. So whatever percentage you want to see, that you can calculate from percentile. So number total, this gives you the total count. Selecting sales, I'm clicking on OK. So the total number of data is 100. Okay. So if there is anything missing, I'm deleting these 2 cells now. I'm going for number of missing. So you can see it is calculating even the stars that is there below that. Okay, so I have already said you. Let me delete it and show. So generally stars, it indicates a value is missing. Now calculator, I'm going for number of missing. I'm selecting sales. Sorry. I'm selecting sales and clicking OK. So the number of missing is 2. These 2 are missing. Okay. So calculator will give you some basic details about your data. What we saw as descriptive statistics, you can get all those details in calculator. Let me check standard deviation also. Yes, standard deviation. Standard deviation of sales is 65.75. Okay, so this is calculator will give you all the basic details, descriptive statistics, mean, median, mode, standard deviation, variance, all these details you can get from calculator. Now let me go for pattern data. If you want to create some data out of, let me put, I want to store this data in C10. I want to start from 200 and end with 400, steps of 1, and I'm clicking OK. So I'm getting here, the data is created 200 to 400. Okay, pattern data. Here, arbitrary set of numbers. I'm going to store it in C11. Here you can put 200 to 300. So you can get these values here also. Okay, I have from 200 to 300 here. So if you want to create data immediately, you can use this pattern data option. Okay. There is one more option to check all the descriptive statistics. Look at this. I go to stat, I go to basic statistics, and I select display descriptive statistics. So what I have shown you so far is basic tools and techniques. Okay, basic features that is available for creating data. That is what I have shown you so far. I didn't go to any statistical analysis so far. File, edit, data, and calculator, all these I have just shown you how to create data using all these options. Now I'm going to show you an analytical tool. So this is a very, very simple tool. You can use it most of the situations to display your descriptive statistics. Displaying descriptive statistics. I want to select sales and I want to study the descriptive statistics in that. I'm clicking OK for that. You can see all these details here. So what are all the contents you can see? What are the contents you can understand from this?
Number of samples, mean, standard deviation,
Hmm.
such as results scale.
So you have mean, you have standard deviation, you have minimum, maximum. Then what is this Q1 and Q3? Any idea? Q1,
No.
Q3. See, I said the same thing in percentile also. Q1 means, Q means quartile. Quartile. Okay. Q1 means quartile.
Is it 25%?
Yes. See, 25% of the data is below this value. 309.3. Okay. 319.3. 25% of the sales is below this value. And what is Q3? 75% of the data is below this value. And what is median? 50% is below that, and 50% is above that.
What
Okay.
is SE means?
Standard error mean. Standard
Okay.
error mean, the possibility of error in mean, plus or minus 14.
Okay.
Okay.
What is N star? N.
Missing
Okay.
data.
Okay, thanks.
Okay. See, this gives you a basic description of your data. Whatever data that you collect, immediately when you go for descriptive statistics, you will come to know mean and standard deviation. I think you will mostly focus on only these two aspects in your organization, right? Mean and standard deviation. Are you looking at standard deviation or only mostly average?
Standard deviation also required for us, such as percentage of tolerance, testing categories. That type of data also needed.
Okay, some specific data you're going for standard deviation also, but not for everything.
Yes.
Okay. Now I'll go for some graphs. Okay. So what are the graphs you have known here? Any idea? What are the graphs you know? Scatter plot, matrix plot, bubble plot, marginal plot, histogram, dot plot. Any of these graphs you know?
We have used bar chart and pie chart.
So you have used bar chart. Okay.
Yeah.
Just now we learned about this scatter plot, right? Scatter plot.
Yeah. The correlation.
Scatter diagram, we have learned about it. Yes. Let me, before going to scatter plot, I will go for some basic graphs like dot plot. Then we can go for that. Okay. Let me show you dot plot. Dot plot of sales. This is the dot plot. And what is the interpretation you can get from a dot plot? What is the idea you're getting from a dot plot? This is sales data, and you have dot plot here. Yes.
How many numbers are fall between the 350? How many values are there? 385? How many numbers are there?
From this picture, where most of your data is concentrated?
350 to 385.
350 to 385, 420, we can say, right? Most of your data is only here. Most of the days your sales is between 350 to 420. Very few days you have very high sales of 455, and another days you have very few days you have something around 210 or 245, like that. This is dot plot with groups. I want to give a dot plot based on ad agency. I have two ad agencies. And how is the sales through them? You have alpha ad agencies sales and omega ad agency sales. What is the difference you can see here?
Omega is higher.
Omega is performing well, right? And compared to the sales of omega is consistently it's more than 350. But here it ranges from 200 to those 70, 380. So previous picture, it is a combination of both. So we are not able to identify this pattern. We can identify this pattern here. I can even stack this together. Let me see that. I'm selecting ad agency in categorical variables. What do you mean by categorical variables? That is nothing but discrete. Okay. Discrete data is also called categorical data.
Okay.
Both combination. So you can very clearly come up from the picture that omega is performing well. Most of your alpha is less than 350 and most of your omega data is more than 350. So stacked is combination of both together. This is dot plot. Now let me go for box plot. Box plot of sales. This is something a very useful tool. We have seen this Q1, Q3 in descriptive statistics. If you want to understand more about Q1, quartile 1, quartile 3, you can use this tool, box plot. Any idea what is this box plot? What is the interpretation that you can make from a box plot?
So it will
It's
show
like a range between.
It will take, see this box, when you keep your cursor inside the box, it will show all these details. Q1, the lowest line that you have is called Q1. What do you mean by Q1? Just now I said.
25%
of the sales.
Yes, so 25% of the sales is below this line. You understand? And this is median. 50% is below this line and 50% is above this line. Okay. And you can see Q3 is at 408.25. So 75% of the sales is below this value, that is 408.25. And you can see two lines here. This plot is also called box and whiskers plot. Any idea what is this whiskers?
No.
Whiskers means cat's, what do you say, mustache, cat's mustache. Okay, it looks like that, right?
the extension. Yeah.
So this is also called box and whiskers plot. You can see the whiskers, it goes up to 450. It's going up to 450 here. You can see 202 is the lowest one and the highest one is 450. So what is the box plot showing you is most of your data is within your box and there are some data that is going beyond your box. So it gives you overall range of your data. Now I'm going to change something in your data and just see what is the result. I'm going to change this to 10.
So viscous means that minimum and the maximum values.
No, viscous starts from 202.
Yeah, minimum.
Yeah.
Maximum 450.
Maximum is 450.
Okay, that's like we can consider minimum and the maximum of the values.
I'm showing you one more thing so that you can understand that. This. See, I'm changing the first one to 31. Okay. So now I would like to get the results. See the results now. Can you see this change? Can you see the star here? This is 31.
Okay.
Okay. This is the 31. This is called an outlier. Outlier. Any idea what is an outlier?
Out of range, not within that range. It's something
Yeah.
like a
Out of trend, like.
Yes. So you cannot consider that as minimum. Understand? You cannot consider that whiskers as minimum. So you will also have something beyond that that will be displayed as outliers. Understand? So
Yeah.
outlier, every day when you are working, if you use box plot, you can identify outlier. Who is the outlier? Which department is the outlier? Which day is an outlier? Which product is an outlier? You can identify all those from box plot. So one of the major uses of box plot is identifying outliers. Identifying outliers. That is a major use of box plot.
For the mean calculation, outlier will be considered or not?
Anything. That is what we are showing here. No, that will also for even in that when I am discussing with you about average or mean, I said you something about extreme values. That is what is extreme value here.
Okay.
So always, if you see extreme values in a data and if you put a box plot, you can identify which is that extreme value in your data. And you can identify the reason what happened on that particular day. For example, if you're plotting the rejection data here and you're getting an outlier on one particular day, you can identify the reason what happened on that one particular that the rejection is very, very low, so that you can replicate the same situation on some other days also, right? So this helps you to identify the causes related to this. Now I'm going for with groups. So based on ad agency, I'm doing a box plot. We're going to do a comparison. So look at the comparison box plot of alpha and box plot of omega. So tell me what interpretation you can make here.
Omega doing best sales compared with alpha.
You're very consistent, right?
Yeah.
The variation is very, very less.
Yes, yes.
Variation is very less and they are always very consistent towards a target. But alpha is not towards a target. They are the variation is very high. Always, whenever you want to make any improvements in your process, a process which has less variations, you can bring out more changes there than a process which has more variations. So omega is more predictable. So you can depend more on omega. Now, let me go for interval plot. Interval. This is an interval plot. Have you seen this anywhere? Interval plot like this. What does it indicate, this interval plot? What do you mean by this interval?
Minimum and maximum.
Can you see this 95% confidence interval here? I can say 95% of the times my data will be, my sales will be within this, my mean sales will be within this range. What is this range? Somewhere around 295 to 376. 95% of the times I can say my sales mean will be within this values. Okay. Interval means confidence interval. Generally, this confidence interval is calculated for 95%. So this is one of the tools that we use in hypothesis testing also. I have mentioned you about ANOVA. It is one of the types of hypothesis testing. So the use of interval plot is you're identifying what is a range where 95% of your data will come in the future. Okay. That is called confidence interval. That is called confidence interval. And if you keep your cursor there, it will display the mean. And it also display the confidence intervals. I'll go for groups. Interval plot with groups. I'm selecting sales here and I'm selecting ad agency here. Looking okay. So look at the confidence interval. So here the mean is 399. The mean is 272. Not getting displayed. Yeah, okay. So you can see the interval for this is 210 to 333. So most of the times, 95% of the times, they will be within this two level only. When it comes to omega, it's not. Yes, 95% of the times they'll be between, what is the value? Interval 379 to 419. The sales, 95% of the times the sales will be between 379 to 419. That is interval plot. Then we'll go for individual value plot. Individual value plot. Sales. This is more or less similar to dot plot. Dot plot you got horizontally. This you're getting vertically. Okay. So this indicates mostly your sales is beyond 300, right? There are some days your sales is below 300. Every value is plotted as an individual value here. That is individual value plot. Now let me go for groups. So it is mostly similar to dot plot. Instead of horizontal, you are presenting it as vertical. So I'm selecting sales in graph. I'm selecting ad agency here. Clicking on, sorry, I went to dot plot. Individual value plot. So I'm selecting sales in graph variables and categorical variables. I'm selecting ad agency. Clicking on OK. Fine. So now you can see the difference. Same what we have seen in dot plot or box plot. The variation is very less. The variation is very high. Time series plot. Sales. What does it indicate? What does it indicate? The time series plot. Sales time series plot. What is the indication you get here?
The
Can
changes
you-
based on the time.
Overall pattern, is it showing an increasing pattern or a reducing pattern?
Increasing pattern.
Okay. Let me go for groups. Sales, ad agency. Okay. So you can see the same interpretations we can. So all the graphs gives the same interpretation that omega is a high contributor of sales and alpha is low contributor for sales here, right?
So the index refers to the what column? 1 to 100.
Index
Refers to what column? Where we get these index values?
Index is the time.
Okay.
So the
But
different
we are
date.
not
No,
in this time, right?
it is actually calculating that. No, you have mentioned it here, right? Different days. Each and everything it is taking. How many data you have, it will take based on that. We have more. We have 100, then it will even show that it will come up here closer like this.
So it's number of data. Nothing. Index is nothing but a number of data.
Yes.
For time series, do we need to give the data date? Is it required or is it not relevant?
No, all these are going to show the same thing. So
Okay.
not necessary. It will automatically indicate it. So you need not mention the date or time in that, right? It is showing you the progression. So it will automatically indicate that.
Okay.
So histogram and line plot. We'll see that later after the lunch. Okay. So we can join again at 1:45, right?
Sure. Yeah.
Okay.
Yeah.
Thank
We'll
you.
join after the lunch. And the lunch, after the lunch session, it will be a hands-on. I'll send you a file.
Okay.
Somebody from your side should share your screen. I'll give you the instructions and we'll be doing all the tools and techniques.
So
Okay.
Dhanamohan will share the screen from our side, representing us.
Okay. Not an issue. So I'll give you I'll send you right now I'll be sending you a file now. You can copy and you can paste it into your Minitab and we can start working on that in the afternoon.
Okay.
Okay. Yeah. Thank you.
meeting is being recorded.
So the next tool that we can see is bar chart. You said you're already using bar charts, right?
Yes, sir.
So bar chart is used for categorical variables. Let me show you the data first, then I will go for bar chart. See, this is the data that you have here is flaws, that is type of reject, okay, type of defects. And I'm going to put a bar chart for this. So the data is a text data. So you are using bar chart for that. I'm going to graph, bar chart, simple, selecting flaws. Okay. This is a bar chart of flaws. So you have 4 different types of flaws here. And the data is missing below that. So that is showing as a separate chart. I'm just deleting it. Yes, now I'm going to update the results. Can you see the chart? So this is bar chart. So I have all the 4 types of defects, that is flaws, that is displayed here. And let me go for cluster. I'm selecting flaws in categorical variables and period. So I'm going to graph, bar chart, clusters, selecting flaws. This period is whether it is coming on different period like day, evening, day shift, evening shift or night shift, or in the weekends. That is what is displayed here based on different period. So we are grouping the flaws here. Stacking it, same grouping by stacking. I'm going to flaws and period, selecting both these columns. Clicking it as okay. Now you can see. So what is the interpretation you can get here? Most of the flaws are in
night shift.
Night shift. Now let me go for line plot. First, let me show you the data. Then I will explain you this. The data I have taken, I'm taking for this line plot is this sinter time. The temperature you're going to weld your metal, and then the strength of your metal joints, and what is the metal type that you're going to use. What I have, I'm going to identify from line plot is which metal type and which sinter time combination, if I'm going to use, I can get maximum strength. I can get maximum strength. So that is what I'm going to check in this. So let me go for the data. I'm going for line plot. I have selected strength in the graph variables, metal type in X, and sinter time in Y. So now I'm clicking on OK. This is the result I'm getting here. So now give me the interpretation. Where the strength is more? Strength. Where the strength is more? Which metal has more strength and which combination has more strength? You have metal 1, metal 2, and metal 3, right?
Yeah.
So I'll repeat it again. Line plot is used to identify when two variables are there, combination of those two variables, which gives maximum output. Okay. So one is the time that I'm going to take for welding the metal. That is one thing. Other one is what is the type of metal I'm going to use. Based on this, I have the strength of the joint. Okay. So which joint combination has maximum strength now? You can see the green color is 200 sintering time.
Yes.
The blue color is 100 and red color is 150 sintering.
150. Yeah.
So you can see metal type 2, right? Metal type 2. This is metal 1, metal 2, and metal 3. Metal type 2 with a combination of sintering time of 150 gives the maximum strength. So you should always use this combination to get maximum strength of your welding joints. Okay. So when you have two X variables and you have one Y variable, and you want to predict the results of which combination of this X will give you maximum result of your Y, you can use this line plot.
Got it.
To scatter plot that we discussed today morning. I discussed with you scatter plot. So for scatter plot, go to graph, select scatter plot, select the option with regression. Because if you select this option, you'll get a line. So you can easily identify the pattern, whether it is positive or negative. Okay.
Yeah.
So I'm going to plant length is I'm considering plant length and soil density. So which is Y, which is X here? Plant length, soil density. Which is Y, which is X? C53 and C54.
Soil density X.
Soil density is X and plant length is Y. So plant length depends on soil
density.
So I'm selecting that. You can see that I have selected plant length in Y and I have selected soil density in X variable. I'm clicking OK. Let's see the results. Now look at this and tell me what is the relationship you have. Is it positive or is it negative?
It is positive.
Positive.
This positive relationship. So what does it indicate? How do you interpret this? A soil density
Increases plant length.
Yes.
Soil density increases, plant length increases. Okay. Now let me go for another combination. So here Let me go for plant length. Next, I'm selecting water in gallons. Now let me see the relationship. Yeah. So what is the difference you see between that and this? This is plant length and soil density. And this is plant length versus water in gallons. When you
First one is
see,
a positive. It is very flat.
Linear with slightly positive.
yeah, this is called weak positive relationship. Okay. It is weak positive. This is positive, but it is weak. But this is strong positive. You can very confidently, you can say that soil density is positively related with plant length. But we cannot say very much confidently that water is positively related with plant length. This is where you are supposed to do correlation analysis. So I said something about R value today morning. You remember that? R value? How much should be the R value? Positive, negative? I said R value, Pearson's coefficient of correlation. Do you remember that? I was mentioning the positive correlation, it should be 0 to +1. The negative correlation, it should be 0 to
0 to -1.
Minus.
If it is 0, it is no correlation. Now let me check the relationship between plant length and soil density. See the R value, how much is that? 0.6.
0.6.
So let me know what is the relationship.
Positive.
Positive relationship. It is more than 0.5, so it is strong positive relationship. You need to remember, if it is more than 0.5, it is strong positive relationship. Okay. Now let me check the same correlation between plant length and water in gallons. Can you see it?
0.1.
Value is just 0.1. That's the reason it was flat when you saw the picture before. Scatter plot. Here also you will get scatter plot, but you will not get that line. You will not get the regression line as you got in that graph. Okay. That's the reason we are doing scatter plot here and we are doing correlation here. So for correlation, you need to go to stat, go to basic statistics, select correlation, select your Y variable and X variable and click OK. You'll get your R value. Based on your R value, you're supposed to decide whether it is positive relationship or negative relationship, whether it is strong positive, weak positive, strong negative or weak negative. So all these you take decisions only based on R value. Okay.
There is two correlation options available. Which one we have to use?
Where?
Regression?
Correlation.
Yes.
Only one correlation.
Oh, okay. Covariance.
Different. That is different.
Yes,
Only
okay.
one correlation. So now let me show you regression. So what is the use of regression? What is the use of regression?
To get a equation from variables.
Yes. What is the prerequisite to do regression? What is the prerequisite to do regression?
Correlation.
Yes. Only when two variables are related, they have
Related.
positive or negative relationship, then you can go for the regression. Now, I'm going to, what should I see? I have 53, 54, 55, 56, and 57, and 58. You see all these plantlet, soil density, water in gallons, fertilizer in kg, sun hours, and watering time. Or among all these variables, which column is your Y? What should I select in response?
Plant length.
Plant length should be selected in response. Now tell me, all these variables are continuous or discrete? Remaining. Soil density, water in gallons, fertilizer in kg, sun hours, watering time.
Continuous.
All are
Yes.
continuous data.
Continuous.
You need to remember your data should be continuous to do this. So I'm selecting all the X's and I'm clicking yes, okay. And I'm getting an equation here. You can see plant length is equal to 325.4 plus 0.0675. So let me know the relationships now. Sun hours is negatively related, right?
Yes,
Get
minus.
minus there.
Yes.
All other variables are positively related. See, this is called multiple regression. When you have more than one axis and you want to predict Y, you want to predict the length of plant length from all these axes. You can use this equation, but this equation is very complicated and we have more axes. So what we are supposed to do is we have to reduce the number of axes. How we can do is you just need to look at this coefficient value. Can you see this coefficient value?
Yes.
Here. See this coefficient value, irrespective of the symbol that you have as positive or negative, which comes highest, which the coefficient value is highest for which X?
Sun hours.
Sun hours. So as I said to you, don't consider the symbol, okay? Because positive or negative, it will show the impact, how much effect it has on your plant length. So as we can see in this example, sun hours is the highest influencing X that affects your plant length. Now, I'm just going to add it approximately 22, 24. So let us consider 23, 25, 28, 30, 30, 31, approximately 31, excluding the constant. Okay. So in this 31, 22 comes to around how much percentage? 31. It comes to around 70%.
Yeah.
Yes, 20.
Yeah. See, why you want to focus on X's, which is very, very negligent, which has very negligible effect on your plant length. There is no use, right? So if you take the top two, 22.95 and the next one is 3.80. Yes. If you just take these two, it will contribute to 80% of your excess. So what I'm going to do now is I'm neglecting the remaining excess. I'm taking the 80% excess and I'm going to do another regression equation. So let me go for that. I'm going to regression and I'm selecting here. So fertilizers and
Sun hours.
right. Yes. So I'm selecting only these two now. Now this is my final equation. Okay. So with this, we are going to predict your plant length. Now, as I said to you before, today morning, I was explaining to you about this broken chips percentage example, right? So now here, what you have to do, you can give your own values for fertilizer in kgs and sun hours. For example, I want to know how much will be the for 2 kg fertilizer and 2 hours sun time, how much will be my plant length? You can substitute that value in the place of fertilizer in kgs and sun hours and get that value of plant length. And again, you can give some other different values, 3 fertilizers, 3 kg fertilizers, and again 2 hours of sun. What will be my plant length? So like this, you can use different combinations and in this equation, and you can predict the value of plant length. So whichever combination gives you the highest plant length, then you can use that combination in future. You understand?
Yeah.
So remember this fertilizer in kg and sun hours, that is in brackets. You have to substitute the value in that place and multiply and get the values. Okay. After getting this equation, you can take it to your Excel and you can multiply and you can predict the values. Whichever combination has the best fit, you can use that as your solution, best solution. Now let me go for gauge R and R. Before getting into that, let me show you the data. Can you see this reference value?
Yes.
Reference value called rating appraiser. Can you see that?
Yes. Yes.
Okay. Let me explain you the situation and the data what you have here. There is a manager who rates the calls that comes to this organization, and the rating that he has given was mentioned here as reference value. So the manager's value is reference value. Okay. And second column is call. Which call he has selected and he is rated, that was mentioned here. You can see call 2, call 3, call 5. So whichever call he has selected, the call number was mentioned. So that is call. Then you have rating. What is this rating? You can see these people, Mike, Klaus, Krebs, Datko, John, all these are team members. He is giving the same calls to his team members and he is asking them to give rating for those calls. And they are giving the rating and their rating is given in this column, rating column. Right? So you understood the situation. So the manager has given rating for a call and he is giving the same calls to his assistants and he is asking them also to rate the calls. Now, the rating that was given by the manager and the rating that was given by the assistants, both should match or not match?
Both should match.
Both should match. So that is what we are going to check whether it is matching or not. So how much should be the matching percentage?
90.
Today? Above 90%. Yes.
9. Yeah.
So go to quality tools, attribute agreement analysis. Okay. I'm showing it again. Go to stat, go to quality tools, go to attribute agreement analysis. Why you're going to attribute agreement analysis? Any reason why you're going for that option? What is the data that you have here? What type of
For
data you
matching,
have?
for
Continue.
matching purpose, we are using.
Yes, come again, sir.
For matching purpose, we should use attribute.
For matching, you should attribute. Here you have 4 columns. You tell me which columns help you to decide whether it is attribute data or continuous data.
Rating.
Exactly. So rating is Attribute data, you
Yes.
cannot give any value. You will have only 1 to 10 or 1 to 5. You have to give only any one of those values. You cannot give
Yes.
any values here. You cannot take any value. So that's the reason. So if your data is attribute data, the option is go to start, quality tools, and attribute agreement analysis. Now tell me which columns should be selected in this field. In attribute column, which column should be selected?
Rating.
Rating, yes. So I'm selecting rating there, then examples,
Call.
call. Appraisers, select. Appraiser 1. Then known standard attribute,
Reference value.
reference value. Click OK. Let me check the length. Yeah. So let me go back to that. The results here. So look at the matching percentage between the appraisers. 1 minute, 1 minute. We'll start from here. So look at the matching percentage for each and every appraiser. How much is the matching percentage?
60 to 80.
So it is not as per our requirements, right? As per our interpretation results, it should be more than 90%. So none of the appraisers are within that above 90. So what could be the reason? You should identify that, whether it is because of methodology or whether it is because of the instrument that they use, or is it because of their knowledge level? So you need to understand that and correct it. Now coming to between appraisers. Between appraisers, it is very, very less. It's only 10%. Assessment agreement is only 10%.
10.
Out of 10, only 1 is matching. Okay. Then all appraisers versus standard. Out of all appraisers value, how many is matching with your manager's value? So there is only 1, that is also 10. So the interpretation says your gauge R&R, as per your gauge R&R test, the methodology that you follow to collect data in your process is not up to the level. And what you're supposed to do now, you're getting it as 10%. So what your repeatability and reproducibility is very poor. So what are we supposed to do now then? What is the action plan?
To identify the root cause and redo the cage armor.
Identify the root cause. how
whether
You
equipment
are
is equipment or operator, who will be do the wrong, like
yes, whether it is equipment or operator.
operator.
Okay. See, generally this agreement, attribute agreement analysis is somebody says okay and you say not okay, somebody gives a rating and what rating you give, only such type of data you go for attribute agreement analysis. And now when you go for data like width, height or temperature, all these continuous data, then you should think about
Equipment.
continuous gauge R&R. Continuous gauge R&R.
Okay.
Let's see how to do that. So the data that I'm taking here is these three data. You can see C38, C39 and C40. C38, 39 and 40. What they are doing is they're manufacturing the products and they're calculating the value of each products based on weight, and that is what is mentioned here. So we have different people who are calculating the value. We have Sham, we have Rick, we have Samson, Rinku. So the same product is, the value is calculated by different people. Product 1, 4 times by Sham. Then product 2, 4 times by Sham, like that. Product 1, 2, and 3. We have 3 products. It was done for all these people. What they're calculating is value of the product. They weigh the product and they are calculating the value of the product. So they are checking whether there is any difference in the value they calculate or not. So let me just copy and paste it. One minute. I'll just copy. Okay, fine. So now the option that I have to select for this is the option, how I am going to do gauge R&R for continuous data. The option is go to stat, quality tools, gauge study, gauge R&R study crossed. Okay. So quality tools, gauge study, gauge R&R study crossed. Now I have these 3 columns. What column should I select in this field? Part number. Part number, which column should I select? Product, yes. Product, I'm selecting there. And operators, appraisers. Measurement data, I'm selecting value. Method is ANOVA method, I'm clicking it OK. And this is the result, I have got it here. You have to go down and look at something called percentage of study variance. Okay. Can you see this? Gauge evaluation. In gauge evaluation, you have to look for percentage of study variance. How much is the total gauge R&R percentage? 26%. So is it acceptable?
No,
So how much should it be?
it should be above 90,
No,
above 80.
no. This is for continuous data. Let's say for continuous data, it is different.
Yes.
So how much is that? Here it is variation. You need to remember that for attribute data, what we are seeing is actually matching percentage. But for here, what we are seeing is variation percentage. That is different. So it should be less than 10%. Less than 10%. Variation should be less than 10%. If it is between 10 to 30, it is maybe acceptable. More than 30, it is not acceptable. So we are in maybe acceptable category. Your organization can accept it or can reject it based on your own policies. Okay. But if it is less than 10%, it's sure this is not acceptable. Okay, fine. Now you have it is at 26%. Now what you're supposed to do with this? After this, you have identified the variation is 26%. So what do you have to do after this?
We have to minimize the way to find the variance.
So that what you should identify. Again, whether it is operator side or equipment side, methodology, what is the issue that you have? You need to identify that, right?
Yeah.
Yes.
So for that, the most important hint that you have is this number of distinct categories. Today morning, I was explaining to you about a concept called resolution. Remember that? In Gauge R&R, I was explaining to you about resolution. Repeatability, reproducibility, stability, and resolution. What do you mean by this resolution? Resolution.
It's mentioned as a unit of measurement, like.
Yes, exactly. So units of measurement. Okay. See, this for this number of distinct categories will give you a hint whether the units of measurement that you use is right or wrong. This number of distinct categories should be more than 5. If it is more than 5, then it will be your units of measurement, your resolution is good. Okay. If it is less than 5, it is not good. What is this number of distinct categories? Your data can distinguish your methodology can distinguish your data into 5 distinct categories. Okay. But if it is only one, then you cannot distinguish between one data and other data. What I said today morning in the race example, you are considering all 5 people as one, right? They are running at the same, you say everyone are running at the same rate, and you tend to give first prize to 2 to 3 people because you don't have the proper measuring instrument with you. You understand the difference? But when you have a better instrument, it can distinguish the data into 5 categories or 6 categories or 7 categories. So when you go to the lowest units of measurement, it can categorize your data into many categories and show you the variations. So here it is 5. That's the reason it is in maybe category. Right? It is exactly 5. If it is going to be more than 5, it will be less than 10. So where you should focus now? You should focus only in this aspect. You should improve your resolution. In most of the situations, resolution will be the problem. This resolution, number of distinct categories and your gauge R&R percentage are very closely related to each other. If you see some changes, increases, when your number of distinct category increases, your gauge R&R variation percentage, automatically it comes within 10. So when you go back to your process, you can check this point in gauge R&R so that you can correct it as soon as possible. Okay. Let me go for ANOVA. So ANOVA, what is the idea I gave to you about ANOVA. It is used for,
Probability.
it is used for comparing more than
Variance.
two samples. Okay. ANOVA means analysis of variance of means. So I said today morning there are 3 teams that is performing, and which team? Is there any difference between the team or not? One, you said there is no difference. You said there is difference. I said there is no difference. These two are assumptions. Which assumption is true? Which assumption is wrong? So that is what we have to identify. So let me show you the data first. So you can see week 1, week 2, week 3. Okay. All these are the rejection percentages in week 1, rejection percentage is week 2, and rejection percentage in week 3. Now, what we are going to identify using ANOVA is there any difference in the rejection percentages between week 1, week 2, or week 3? Are they different or are they same? That is what we're going to check with ANOVA. Let's see that. Go to Stat, ANOVA, one-way ANOVA. I'm going to select all the 3 weeks data. Week 1, week 2. See, response data are in separate column. We have responses in separate column. So we are going for that option and click OK. Your p-value is 0.05. The p-value is 0.05. Okay. Can you see this?
Yes.
And I was mentioning you about one more value today morning. What is that? Alpha value, right?
Yes.
P-value, you should compare p-value with alpha value. Alpha value is always 0.05 for all the tests. Whatever test you do, alpha value is 0.5. You can see here, alpha value is 0.05. Okay. So the alpha value is a significance level. This is a very detailed concept, so I may not get into the in-depth analysis of hypothesis testing. So I'm just giving you how to interpret the result. Okay. So you have alpha value here and you have p value here. So p low, what is accepted? Can you see? Null hypothesis, all means are equal. Alternate hypothesis, they are different, right? Now, what did I say today morning? P low, which is accepted?
Difference is acceptable. Alternate.
Alternate is
Alternate.
Acceptable.
P high, null is
Null
accepted.
is accepted.
So when both are equal, you should consider P is actually low. Okay. When both are equal, you should consider P as low, and you should go for accepting the alternate hypothesis when both are equal. For example, if your p value you get is 0.01, then p is low. Alternate is accepted. If you get 0.1, then p is high, null is accepted. So null is accepted means there is no difference between week 1, week 2, and week 3. Okay. So the interpretation that you make from ANOVA is very simple. You just need to compare the p-value and alpha value and decide which is high and which is low, whether null is accepted or alternate is accepted. This you do only for samples that goes beyond 2 samples. If you have more than 2 samples, that you can think about using one-way ANOVA. There is one more useful tool let me explain to you that also. This is actually not a part of basics, but you should have heard about this analysis. Have you heard about cause and effect diagram?
Yeah, this is a fishbone diagram. We are familiar. Yes.
You do this in minute.
Yeah. Yes.
So should I go ahead and explaining it, or
Maybe Nikki, you can touch maybe few minutes, maybe not about.
okay? See what you have. You can do cause and effect diagram in Minitab. So I have already. I'll just show you the data first. Let me- Okay, so I have the data here. You can see what are the manpower causes for rejections, machine causes, material, method, measurement, and environmental related causes for your rejection
Yeah.
that I have mentioned here. Now I'm going to draw a cause and effect diagram for that. Cause and effect. I go to causes, select the causes. I have to double click on man. Second one is, you can see the label is machine, so I have to select. I have selected it. To select man. For machines, I select machine. Materials. Method. Measurement. Environment. So what is the effect? Rejections, right? Rejections. Title. Causes for rejections. So I'm clicking it as, okay. So getting a cause and effect diagram. Cause and effect diagram is something that is used for categorization of your data. If you know the causes and you want to focus on improving those causes, you can categorize those causes into these categories and get by using this diagram.
So we use this manually actually, not with the Minitab. Maybe in future we use with the Minitab. We use for complaint investigation analysis. Yeah.
Okay. So that's the reason I showed you, because these are very common tools that is used in most of the organizations. You can use this cause and effect diagram also in Minitab. Okay.
Great. Yeah.
So now I think, shall we go for a hands-on? I have sent you the data.
Yes, I have received.
Mohan, you can share the screen, Mohan.
I'll just stop my screen.
Other than Mohan, anybody want to share also? I'm fine.
We can take it in turns.
Yeah, Mohan, let's start first, then we can go to Prasanna, then Pradha.
Can you able to see my screen?
Yes.
Yes.
This is Dhanamohan, Mr. Dhanamohan's screen, right?
Yeah. So I'll open up the data.
Yes. Click OK. Got it.
Yeah.
The disadvantage with directly opening with the Excel is you get all these missings. Okay. Go down. Go down. So wherever the data is missing, it will show it like that. If you just copy and paste it directly into Minitab, then that may not happen. Okay. So that
Okay.
is something that you'd have seen even in my data that was happening here, right? So if you
Yes.
just copy from Excel and paste it here, then that may not happen. Okay. So let's do this. Now, shall we do descriptive statistics? So
Yeah.
where we can do descriptive statistics? How do you calculate descriptive statistics? The option is in stat. Go to stat. Yes. Display descriptive statistics.
Statistics.
So select whichever column you want. You can even go for weight.
Okay.
Click on weight. Click OK. You got your descriptive
We
stat.
get the means, missings,
Yes.
and Q1, Q3.
Q1 is 25%, Q3 is 75%.
Q3 is 75%.
Okay. Now, I forgot this histogram. So let us do histogram. Go to graph, histogram, select simple. Go to sales. Click OK. So what you can interpret? Is it normal?
No, it is not normal.
It is not.
There is no bell shape.
It's not well shaped. There is one more option, with fit. Just go for that. Go to graph, histogram, with fit. Sales, double click on sales and click OK. So this is how you should actually get, and this is how it is actually for you. Okay. So with fit will show you how it should be. So you need to what generally when you have a data like this, what you're supposed to do when your data is not normal.
So we have to increase the numbers. The data should be more than 100.
Exactly. So you need to increase the numbers because your prediction depends upon how much data you use. So this histogram gives you only that. I think what you are seeing should be capability analysis. So let me go for that. Go to stat, quality tools, capability analysis. And even for capability analysis, you have to go for normal. Okay. Click on normal. Now sales, subgroup size. What is the subgroup size? At a time, how many samples are you going to select? Sales daily, one data. So one. Subgroup size is one.
Yeah.
Now, you have to mention upper specification, lower specification. So you can just minimize the histogram and look at that worksheet. You have to close it. Look at the worksheet. Okay. I changed that 31. So just change it to 200. The first one, first data and sales. Yes. So now, if you look at the sales data, it's mostly from 200 to close to 450 or something.
450.
You can delete the data, the missing data which is there below. Yes. Okay. Fine. So now what you're supposed to do is you should fix a target for this. So let me fix a target of 300. Okay. So let me do capability analysis for that. So go to stat capability analysis. Normal. Sales. 1. So here, where you should mention that 300, my target is 300. Where you should mention lower specification or upper specification?
Minimum, maybe it should be minimum. Minimum target means lower only, no? It should
be minimum, huh?
Yeah, because 300 is minimum my target. If it anything over and above, it is well and good, right?
So I should mention in lower specification limit. Okay.
Yeah.
See, for anything increase, you need to mention the target in lower specification. For decreasing, for rejections, you should mention in upper specification.
Correct.
And when it comes to measurements like weight or length or width, you'll have to mention both upper and lower. Okay. Now we'll click OK. Click OK now. So I think you are mentioning about this histogram.
Yeah.
You used to see, everyone are mentioning, we used to see histogram with specification limits. This is what you mean?
Yeah.
Okay, so here we are not learning, we are not going to discuss anything about histogram. The only thing is whether you are reaching your target or not, right? So you can see the LSL is at 300 and most of the times it is beyond 300. You can see from the picture, the LSL, you can see red line is there. So there are some data beyond 300 and some data below 300.
Yes.
Now, how do you calculate the CPK? How do you interpret that CPK? So what is the CPK your organization?
1.33 at least should be there.
Okay. So 1.33. So that is 4 sigma level. Okay, you are functioning at 4 sigma level.
Yeah.
Fine. So 0.9 is your CPK here. So it's very less. Why it is less? Because you're not able to reach your targets. There are some days you're not attaining 300.
Yes.
You can see 160, 240, 250 are there. That is less than 300. Okay. Now let us change the target and see here. You go to stat. Stat, quality tools, capability analysis, normal.
If I put 200,
Yeah. Now see the difference.
3.07.
There is a enormous improvement was there. So it's beyond 1.33. Right?
Yeah,
Yes.
good.
So what target you fix is very important. For that, we cannot fix something target that is very easy for us. So you should discuss with your team and see whether it is achievable or not. Then you should progressively fix a target and achieve the results. Okay. So the use of this tool is to check whether you are achieving your target or not. That is what we are seeing in capability analysis. When it comes to histogram, whether you have sufficient data or not. Right?
Got it.
Okay, fine. Now you can
How
go
to
for
scale the differences? Like right now, 160 to 240, the difference is there.
162.
160 to 240, the difference between
Now
the each axis.
what is the target you fixed 200, right?
Yes.
So there are most of the days your sales is more than 200. There are some days it is less than 200 and it goes below up to 160. That is what it indicates. Okay.
Yeah.
So you can just minimize it. You cannot close it. You can just minimize it. Finally, you can save it as a project.
Yes.
Okay. Now let us see some graphs. You can go for the graphs. You can try scatter plot. Scatter plot. So which option should we select here? The scatter plot. with regression. You have to select with regression. So you will be having a column named as flash. Look at that. Go down in this. Flash and volts, yes. It is nothing but intensity of your flash and the volts that is used. So here, Y is flash and X is volts, right? So now, click OK. So what is the relationship here?
Negative.
Negative. So how do you interpret it?
Negative.
It is negative correlation. What is the interpretation that you're going to give? What is the relationship? How you're going to explain it between volts and flash? As volts increases,
Flash decrease.
so that is what you need to understand from this. Okay. So if it is negative correlation, as X increases, your Y is decreasing. Okay. Fine. Now you can minimize this. Let's take an example in your organization. What variable you want to take? Go to the last, you can scroll it to the right. You can scroll it to the right. We'll take a fresh column and we'll see there. Yeah, okay. C64 and C65. We'll take these two columns. What between what variable and what variable we can study the relationship in your organization? Correlation, scatter plot. Which variables can we take? So
Can you take temperature and the postmal diameter, Mohan?
Yes.
What is the variable?
Temperature and diameter.
Temperature and diameter. Temperature of?
Temperature of the machine.
Temperature of the machine.
Yes.
Yeah, it's a temperature of the rod or maybe the what do you say, machine? Either. Yeah.
Candle or.
Okay, you can type it. Temperature of the machine. Then
the postmal diameter.
Diameter.
Yeah.
Diameter of C. Oh, okay. Diameter of C. Okay. So, what will be the usual relationship between these two?
The increased temperature will increase the diameter.
When the temperature increases, the diameter will also
increase.
It's directly proportional. Temperature increases, the diameter also increases. If temperature reduces, then diameter also gets reduced. Directly proportional.
Can type some 10 values, then we can check it. Okay. Scatter plot.
Regression. Okay.
Diameter of C. Yes. Click OK.
I think I have to choose. So it's a positive correlation.
It's a positive correlation, yeah.
It looks like a very strong positive correlation, right? Let us check
Yes.
the value of R also. So you can go to stat, basic statistics. Stat,
Stat. Okay.
basic statistics, correlation. Minimize. Check it, do it again. Do it again.
Yeah.
You have got it here. Just click on that correlation.
Bottom, Mohan.
Yeah. Yes. Come down. The Pearson's correlation value is 0.9. Oh, since it is yours is 18, I think it's different. Okay. I was just thinking why I'm not getting a picture here. Okay, okay, okay. Fine. So
Mohan, can you repeat again, Mohan? Maybe you can see the picture. Maybe.
Is there any changes required?
no. Your methodology is Pearson one.
Okay.
Why you are not getting a picture?
I think that is in my version. I'm getting that. Yours is 18, no?
Yeah.
Your version, the older versions, you won't get it. In 15, 16, you don't get it. So you get only the Pearson's coefficient of correlation. So it is 0.9. It indicates that your relationship is positive relationship. That's too strong positive relationship. Okay.
Yes.
And then let's go for check graphs. Go to graph. We'll do a dot plot. You can do a dot plot. Dot plot. Yes. Select simple. Okay. You can select okay temperature. So most of the time,
120.
the temperature of your machine is 120. That is what it indicates here. You can go for next graph dot plot with groups. With groups, you can no, you don't have groups here. You can use a different thing. Select sales.
This one.
Remove the temperature of machine. Sales and categorical variables. You can click on categorical variables based on ad agents. Click OK. Okay. So
Yes.
set it for both these. What is the sales that you have? Comparison. You can minimize it. Now you can go for box plot. Your diameter of seal, you can put box plot. So what does it indicate? Most of your data, you can keep your cursor inside your box. You'll get the results. So your Q1, is 3.6 and Q3 is
3 is
3.9.
3.9.
So what does it indicate?
70% of data is in
75% of the data is
above the average.
Below 3.9.
below 3.9. Yes, below 3.9. And what about Q1? 25% of the data is below 3.6.
7.
3.6.
3.6. Okay.
Q1 is 3.6. So 25% of the data is below 3.6. 75% of the data is below 3.9. Then what does its median indicates? You have the center line. You have a line, right? 3.7. What does it indicate? 50% is above that and 50% is below that.
Below.
Okay. Fine. And now you have whiskers only above the box. There is no whiskers below the box. So you have very few data that is beyond 3.9. And you can go to the data and change some diameter, and you can check for outliers also if you want.
Yeah.
Extreme value you can type.
Put 1.2 something. Yeah.
Mhm.
And you have to do it again.
Okay.
Or the latest version update results is there.
Yeah.
So go to this. So now you got the
Yeah, out of range. Yeah.
outliers. So
Yeah.
it is a fantastic tool where you can identify the outliers. It's the basic purpose of doing a box plot.
Got it.
Can minimize it. We'll go to graph. We'll go for interval plot. So what does it indicate?
The 95% is between 3.2 to 4.1.
95% of the data.
Between 3.5.
It is always a prediction for your future. You
Yes.
can be 95% confident that the diameter of seal will be between 3.19 and 4. In future. So that is what you say as CI, confidence interval.
Intro.
Okay. Fine. Now you can go for individual value plot. Individual value plot. So as I explained to you before, it is similar to dot plot. Dot plot is given horizontally, displayed horizontally, where it is displayed vertically. If you want, we can create some groups to do the dot plot or individual value plot for groups. The diameter of seal, you can mention shift something. You have shifts?
Product type.
Okay, product type. Diameter of the seal here.
Product. So,
What is the interpretation you're getting here?
so A and C is very consistent when compared to B.
Yes, the variation is very, very high.
Yeah.
Mostly all are between 3.5 to
4.5.
but C seems to be very diameter. The diameter should be high or low?
It should be higher.
Oh,
Should
the
be
diameter should be higher. So then, who is doing well then? Mostly it should be the diameter in CC is very less. Whereas when it coming to A, it's a little bit on the higher side. But B is very high variations there. One day it is very low, other day it is high. So you can say A is performing well when compared to B and C.
B and C.
Fine. Go to graph. See. We will go for gauge R&R. Gauge R&R.
Okay.
Go to stat. Yeah, altitudes, gauge study, gauge R&R study, crossed. This is the option for continuous data, right?
Yes.
So go to part numbers. You have the product value in lakhs.
Product.
Product. Just C40, closer to C40.
Appraiser.
Yeah, so operator is appraiser. Actually, in the latest version, it doesn't scroll like this. You would have seen it. It will be stationary. Every time now you have to come down. No?
Yes.
But in the latest version, that is not there. So measurement data, value in lakhs. Okay. So you minimize it, you get the values in the session. Click on the session. Okay.
Finding the table is very difficult.
You see, that is session, yes. So you got the 26% total gauge evaluation, 26.09%. And the number of distinct categories is 5. Okay.
Right.
So let us work out an example for gauge R&R for your organization. What example shall we work out?
Prasanna, can you take the data, Prasanna? Cage and RR, since you are doing familiar. Can you take the data? You have the data, right? Prasanna?
Yes, sir. Data is there.
Can you take the data? Recently we have done, you can take the data.
Yes, sir. I will share to Dhanamohan, sir, because in my Minitab is the desktop. Right now I am attending the meeting through laptop.
Okay, no problem. You share the data to.
Yes, yes.
Recently we done now. We shared Ganesh for plotting the gauge and all.
Yes.
Meanwhile, we'll see something. You can work out attribute agreement analysis also.
Yes, sir.
Go for go to stat, quality tools, attribute agreement analysis. Keep your cursor inside the attribute column. Now scroll it down. You'll be having a column names rating.
Call I take.
Column, yeah, column. Appraisers, appraiser, known standard attribute. Wait, known standard attribute. That is the reference one.
Or
Missing data. Okay.
So delete the data. Minimize. Can minimize the picture. Go to session. Can get the details here. All appraiser is a standard. We are above that. You can see the for every appraiser. You have to still scroll it up. Yes, from here. For each and every appraiser, how much is the percentage of
Only 80 to 60. 60 to 80.
it should be more than 9.
Matching percentages are less.
So this is very, very less.
Less.
Should be more than 90%. Okay. You can do ANOVA.
Yes.
Before that, you delete the data below this week 1, week 2, and week 3. You have to go to stat, ANOVA,
One way.
ANOVA. They are in each, yes. Okay.
All in response, right?
Response data are in one column for all factor lines. No. Select the previous. Go to that option.
Options.
No. The option that is changed, no. Response data are in one column. Here. Click on that. Above the
Can I do?
response. above the response. Yes. Here the response data are in separate column. So you
Okay.
select all the 3 weeks. Click OK. So minimize it, you can minimize it. Session. You have the p-value and alpha value.
P-value is 0.059.
This is the same data you have shared to us. I think there is no change in the data. I think it's the same. Prasanna, did you get that Excel sheet? Prasanna, gauge error?
Yes. Shared to Tanamu. Tanamu.
Yeah.
I sent
We
mail to
mostly
him.
use gauge error so frequently. Mohan, can you share the data, Mohan? Send that.
Yeah, I know.
Prasanna, mostly you used to do that gauge and maybe it would be
Yes,
better
yes,
if you
yes.
share. Since you have problem, maybe Tanamu can do that. Yeah. Who is sharing the screen with the gauge and error?
I will share now.
Okay. Prasanna, can you explain, Prasanna, this one? Maybe before going to that.
So here, 3 operators they're doing. This is for operator qualification. Among the 3 operators, one is standard. That name is operator 1. Operator 2 and operator 3 also need to qualify. So that is this is for overall height measurement qualification. Yes. R&R for overall height measurement.
Overall?
Overall height of the measurement. Yes.
Height. Okay.
Height, yes.
Serial number is not necessary for this, so you can remove that.
Okay.
So what is the data you have here? Trial 1, trial 2, and trial 3.
3.
Right? And this
Yes.
is continuous data. And operators data. So you do it in Excel or Minitab?
We do it in Excel.
You do it in Excel. Okay. So now see the details that you already have our previous worksheet. Look at the data that you how it is displayed. Look at that sheet, so you'll get an idea. You can see the Minitab, what we are doing before.
Can I go down?
You can go to that the data, that file, Minitab file that I have sent to you. No, you are working for today.
Yeah.
So look at this. So here, go to see 38, 39, and 40. These are the 3 datas that we did for continuous. Okay. So your format should be like this. So look at this and create a format. Now you have this height is this value that you have, right?
Yes.
Yes.
Now you should mention product, you should mention appraiser. You have to recreate that for Minitab. You cannot just use as it is, how you have it in Excel. So just look at this and start working on it. You can paste it here. Employees.
Correct. Okay, Mohan.
So all the height you can copy and paste here. Or if you want to type data also, all the height you can paste it here. Yes. One below another.
Here we measured the same samples 2 times we measured. So both results, how we can tabulate here.
Same.
For example, collect one operator. So he is doing it 2 times, same samples measurement.
Trial 1, trial 2. So you see, Kalai, you have mentioned everything as trial 1.
Yes.
That you have to mention trial 2 also. Below. I think you have to paste it below, right?
Yes.
Okay.
I'm going to.
Okay.
Case study. Page R and R study crossed. You can select the appropriate.
C41.
I'm going to take employee appraisal. Employee 38 or 30, 41. Height, yes.
Your length is not same length. Open that. Data. Your day. Show your data. Says it is imbalanced.
Yeah.
So how many check? How many Kalai? How many?
Yeah.
That's what I
Please
think.
change
Kalai
JAWS.
trial 1, Kalai trial 2. Kalai likewise.
No. JAWS, one is in capital, one is in.
Yeah. Correct, Morgan. One is capital, one is small. Change to everything small. Yeah. I about noticed. Yeah. Copy and okay, all just caps. Yes. Now it will be correct. Yes. Correct. Repeat now. Yeah. Correct. Yes.
Got the results. So minimize it. Go to the session. So see. Now you interpret. You give me the interpretation. Come
Again,
down.
why again coming error? Design is not balanced.
No, that is the previous.
Oh, okay.
Come down. Percentage of study variance, gauge evaluation. Go for that. Last one.
Bottom. Yes, 100%.
It's 100%.
So how
Distinct
much?
categories. Yes.
1 should be more than 5.
So where are you? What is the mistake happening? Why it is 100%? How much percentage it should be?
More than 98.
More-
It is matching.
No. This is continuous data.
No,
Yeah.
actually we tabulated wrongly, I think, because Dharma, the table, Excel table. Yes, here top
Go.
Excel table.
So your actual results are how much?
Okay, 1 minute. I will share my screen.
Yeah, you share the screen, Prasant. That's why I told you from the beginning. It's better you share the screen.
So here, for an example, this is the sample number 1. Same sample 2 times collection. Can you see my screen?
Yeah.
Yes, very much. Yes. Please go ahead.
This is the sample number 1. Same samples collection did same 2 times he measured. Likewise, another operator, Sridhar measured, just one measured. So all our same results should be coming because same sample.
Okay.
So
So
likewise, second, third.
okay. So what is the percentage of study variance?
So this is
Come down
already
bottom.
we completed. Study variance 5.19.15.
5.2%.
19.15. Yes.
Correct.
So it is maybe acceptable category.
Yeah.
And you can see the number of distinct categories is 7.
More than 5.
So you have it. So you took it from Minitab and pasted it here. Huh?
Yeah,
Yes.
we are not done. We are taken a support from other colleague. Actually, we don't have experience. So we have taken his help and he shared the data.
Okay.
That's why we want to get it trained on this gauge R&R. We are depending on other person. So
Okay. Now you make it right because you have what you have typed is wrong. The way you have entered is wrong. So why don't we correct it now?
yeah,
The data is right.
now. Yeah.
I'm not sure whether what they have done is right or what we have done it. So let us check the data again.
Okay.
So Minitab.
So this is another one for equipment qualification. This is also same type, 3 operators involved, 3 times we measured, 3 into 3. So like here,
Prasanna, take
first
any one
operator.
data, Prasanna. Don't confuse. At least familiar with one data, at least in front of him, at least get trained. Go to the Minitab and copy and paste the
Okay,
data.
thanks.
Either you or Dhanamohan.
Dhanamon, you can see.
I don't know why you have to step back.
I'm just changing the data.
Check the data, Mohan. Otherwise, freshly key in.
We have to see the same samples.
1 minute. Let me just look at the data. Just show me. Scroll.
Yeah.
So Kalai trial 1, trial 2. So Kalai is checking.
The samples numbers I have changed 1 to 10.
So now Kalai is checking first sample.
Yes.
Then he is not repeating that again.
He is repeating again in the bottom.
Oh, he is checking it again. Okay.
So sample size is 10, Kanagaraj. So each 10 pieces, each operator takes 2 times.
The Kalai checks 2 times each sample.
Yeah.
Yes.
That's check 2 times each sample. Okay. Fine.
Now I'll execute.
Crossed. Okay.
Type. Just do.
Now correct.
Now it is
Same
coming.
Now correct,
Now,
Morgan.
same result coming. Yes.
Correct. Now it is correct.
So you would have known the use of this number of distinct categories. So since it is 7, your resolution is very good. How you are checking the height? What's the instrument you use?
We are
Denymatic
using
Digital
indicator.
indicator.
dial gauge.
Yeah,
Dial gauge. Digital dial gauge.
that's I think a very accurate instrument. So there is nothing that you need to change related to instrument, but still it is not coming within 10. So you need to check if there is any issues that you have in operators or you have anything with the equipment. So I think you need to check that point.
Kanagaraj, can you please brief one by one? Can you go up, Morgan, the session? Can you please brief how to interpret seeing the report? Yeah. Can you please explain the blue header with what is the description of the?
See,
We want to understand how to interpret it. We get the graph and the data. So how to interpret it? Can you please
come
give an
down.
example with this?
You have to interpret to the last gauge evaluation. All these are how you come to that conclusion is based on all these calculations. You're coming to the last conclusion. Okay. You can
Okay.
see the gauge evaluation here.
Okay. So how to interpret this one?
Can you see total gauge R&R?
Yeah, 19.15%.
The total gauge R&R is 19.15%. So what I have said today morning, that gauge R&R percentage for continuous data should be less than 10%.
It is acceptable, looks like
Acceptable
more than 10%.
limits.
Yeah.
It should be less than 10%.
Correct.
And 10 to 30 is maybe accepted.
Acceptable.
More
Yes.
than 30 is rejected.
Yes.
So you are in maybe acceptable category.
Correct.
Okay. So you need to check. Generally, when you are in such situations, you need to check whether it is because of your methodology that you use. Kalai is using one methodology, Sri is using another methodology.
Okay.
So you have to recheck on their methodology.
Okay.
So that could be one of the major reasons why people get different results. So this indicates that people get different results. They're not getting the same result.
Correct.
So one reason could be method. The other reason could be the instrument that you use. But here, the instrument is not a problem. The number of distinct categories, it says that it is 7. So my instrument is giving the right resolution.
So it should be minimum 5, right? Category, distinct category.
As it increases more than 5, your resolution is good. So that is within the criteria that we are expecting. So there is no issues in number of distinct categories. So there cannot be any variation related to the instrument.
Okay.
So it could be either with the knowledge of the person who is doing that, or it could be with the methodology that they use. So you have to address those 2 issues to correct it.
So it means it's purely personal related, not with the instrument related.
Yes.
Okay.
If this shows in our previous example, the number of distinct categories showed just 1.
Correct.
That is your case. Then you should think about changing your instrument.
Correct. You're right.
You should go to another instrument. Okay.
So for any gauge and R, only the gauge evaluation has to be interpreted. Rest of the data needs to be interpreted.
That is how you come to this conclusion. That is based on all these calculations. You're coming to this. You need to look at the total gauge R&R value.
Okay.
Okay.
Okay. Right. Thanks. Kunal.
I think if we test more samples, it will give more clear value. I think since it is values number of pieces tested is very low.
No, usually for gauge R&R, we need not take many because this is only a testing. This is to test whether your data that you have collected is right or wrong. Okay. So for testing purposes, you need not collect more data. Like histogram, you need not collect more data. What you have done is right one.
Okay.
So that is minimum samples, because when you're going for trials, you have taken adequate trials. There is 10 samples is there. That is more than enough. That is fine. But the indication that you are getting is, if you go and check your process, there should be some variation in the methodology that these people do. If you observe that and you standardize your methodology, I think this should come within 10. That should be the strategy that you should use here. If you have any other examples, you can do it for that.
Okay.
Take another one, Prasanna. You done for another table. You show another table now. 133 point
Okay,
something.
okay. So this is for a non-destructive test. We are using this gauge R&R. If destructive means, for an example, some samples are destructive, we cannot use different operator. We cannot use same sample. On the time, which gauge R&R do you prefer?
If you're not going to use in the same sample, then you cannot do it. No.
You cannot do it. Okay.
Repeatability is same sample, same person, repeating it again and again. So gauge R&R doesn't apply to that.
Okay, so the what is this query means, see, for any repeatability not able to do, then what kind of the methodology you can adopt to check whether the method done by the operator is correct or not?
Can you explain that situation?
Okay, so repeatability means same piece we are measuring for one measurement. That is okay, we are doing gauge R&R. For example, if one instrument, the sample cannot be repeatable. It can be destructive. After test, it will be discarded. It cannot be reused by another operator. In the situation, how to compare the three operator, whether they're doing properly the test or not?
See, there you have the result of that sample. No, that is
Correct.
where you have to do attribute agreement analysis. Okay or not okay?
Okay. So, Morgan, can you take the table with agreement analysis with that report? Do you have the report, Prasanna? The FLIPA force.
Yes, sir.
Yeah. Can you take that agreement analysis?
Same table available. Same table.
Yeah.
You can show me that. I'll see, and then we can take it.
That can you show the table, raw data table? Prasanna, you can share screen. Maybe let Dhanamogan do if you have concerns. Share that is raw data to Kanagraj.
Okay.
So this is a raw data.
This is a destructive test, Kanagraj. So
Okay. And
machine
what
is
is
same,
the value
machine
that
is same, operator different, but sample is different.
What is the value you have there? Height, again the same height one.
It is a force.
Force,
It's a
flip of force.
Force.
Newton, yeah. Unit of measure Newton. Continuous.
What is the requirement? Should be between this to this.
Yeah.
For an example, this is used for another equipment, because already you know for height measurement we are using dial gauge. For this force measurement we are using one force gauge. So how we can qualify this equipment through the gauge R&R? Because since it is a destructive.
No. Repeatability and reproducibility is absolutely, you should
Not
be
possible.
able to check the same sample again and again by two different persons and by the same person. Yes. If that is destructible, then I think you cannot think about that. Okay. See, I was explaining to you about another that is attribute agreement analysis. There also the example, do you remember the example? The same call, manager checks and the same call is checked by the assistants. Are they giving the same rating or not? For example, if you're checking a sample, the manager is checking a sample, he is saying it is okay. And he is giving to his assistant. there it is okay or not okay. If that is the situation, then you can use attribute agreement analysis. Okay,
Okay.
but wherever you go, that same sample should be checked by the same person and also another person. Only if that possibility is there, you can go for attribute agreement analysis. Okay. In this situation,
Currently, we are using nested cage arronder or crossed cage arronder for this height measurement. Nested. So, what is the use of crossed? Can you explain? Crossed cage arronder.
here what you are using?
Here we just did the box
Just
plot.
to
only.
box plot only. So there is no
Yes,
gauge arronder.
first.
Just
No,
box plot.
we cannot do gauge arrender.
Ah,
That-
yes, yes.
Yeah. So we cannot do that because the concept itself is repeatability and reproducibility only. So I have clearly given you that using a tabular column, the repeatability is same person, same time, getting the same value, using the same instrument, using the same product. Reproducibility is same product, same different persons getting the same value, same time. Okay. So here you
Okay,
can
sir.
only show a comparison. So as you can see from all these box plot or individual value plot, or you can use what is that? Dot plot.
Okay,
You can use
okay,
only
sir.
that for this. Okay.
Okay, in this case, what is the difference between a crossed arrender and a nested arrender, sir? General difference.
See, that is not actually useful in the basic thing. We are going to see. Mostly it is used only crossed gauge arrender is used for this purpose. Okay.
Okay.
Sorry, can you please repeat? I missed that discussion. What is the difference with crossed and nested?
Here for this purpose, for this gauge R&R study, we use only crossed.
Okay.
So there is no purpose of using nested or expanded. There are different things. So that is used for other studies. If you can see, there are so many studies that is available here. Even in capability analysis or anything is available here. But we need to understand lot other concepts before getting to that. Okay. So that is not applicable in this situation.
Okay.
So if you have any examples for attribute agreement analysis, we can do that now.
Yeah, you can do that,
Okay.
Mohan, the reading overall height, the operator reading. Same you can use the
Same
agreement
cut height available.
Yeah, same value you can use this, Mohan.
Look at here the C44, 45, 46 and 47. So this is your attribute gauge R&R. Do you have anything as reject, not a reject? You have any data like that?
Not fair.
If you have any data like that, then we can work on that.
Okay.
Prasanna, do you want to try any other data with that, or that's it?
I'm taking a visual R&R, sir. Anything for attribute. I'm
Okay.
returning the data.
Yeah, that will be easy now. Yes, that is same sample. Repeatability, reproducibility will be there, right? Yeah.
Yes.
So you can create 3 columns.
Yes.
Meanwhile, we can discuss on regression. So when they are collecting the details about the data.
Yeah.
So where we can apply regression in your organization. So what data that we worked out here is plant length, sun hours, water in gallons, watering time, right? 1y, different x's.
Yeah.
So what data you can use this regression?
We can use the same temperature and diameter. One more parameter that I can incorporate.
Yeah.
I incorporate speed.
Correct. We can use the speed, Morgan. Yeah.
Speed of?
Speed of the machine.
Speed of the
Rotation
machine
per
or
minute. Yeah.
The speed is measured in RPM. Huh?
Yes, RPM.
Yes.
Now let's do a regression for that. Regression, fit regression model.
Fitted line curve.
Come again to regression. Regression, fit regression model.
So response is diameter. Continuous predictors, temperature. We have category.
No, only mention in temperature of the machine, mention yes, speed also. Click OK. Look at the regression equation. So both are positively related with diameter of seal. Can you see the equation? Diameter of the seal is equal to minus 1.11 plus 0.0335 temperature of machine plus 0.004 1 speed.
Yeah.
Now what are we supposed to do with this? What should we do?
So what is the key factor we can able to identify?
Yeah, I think from the results we can see mostly it is temperature of the machine.
Yes.
80% it's decided by temperature of the machine. So you can do analysis only based on temperature of machine and check the regression equation.
Yeah.
You can do another regression analysis with just temperature of machine.
Go to the new stat, Morgan, with the data.
Go to start and do it again. Regression. Fit regression model.
Remove the speed. Yeah.
Okay. So now if you mention in temperature of the machine place, if you're going to mention different values, you can predict the diameter of the seal. So in future, if you're going to work, if your temperature of the machine is going to be so much, you can predict how much will be the diameter of the seal. You understand?
Yeah, got it.
Yeah.
So we can predict based on the form.
For this, you need past data. So I think you must be already having all these past data, right?
Yes.
So based on that, you can derive an equation and you can predict the future. If the temperature is so much, then you will get so much of diameter. So you need to create an environment where the temperature is only so much, so that you can get better diameter of seeds. Okay.
Kanagraj, can you please repeat again the regression equation, how to interpret it? Can you please repeat again?
See, can you see that diameter of seal is equal to minus 0.71
Correct.
plus 0.0346 temperature of machine.
Correct.
Right. Now this temperature of machine is actually in bracket. Okay. So it is in brackets. So now if you are mentioning the temperature of machine is 100, in brackets it is 100. Okay. So 100 into 0.0346 plus minus 0.7.
Okay.
Whatever result you are going to get, that is the diameter of seal at 100 degree temperature.
Mm-hmm.
Okay, like this, you have to predict the value for different combinations. Then you can put it for 70, then you can put it for 90, 80, 120, like that. Different temperatures, you get the diameter of the seal.
Okay.
Whichever has the best. You said already that diameter of seal should be high. So which combination gives high diameter of seal, then you need to freeze that as your best solution in future. You always should function at that temperature. You
Okay.
understand?
Got it. Thank you.
So this gives you prediction of your future based on your
Okay.
current data.
Okay.
But you need to apply it manually. All
Okay.
those predictions, you have to use this equation and you have to apply it manually and
In
get the
Excel.
results.
Yeah, in Excel. Okay. Right.
Yes.
Can you take a break for 15 minutes?
Yes.
Join at 4. Is it okay, Kanagar?
Yes. We are supposed to have break at 3:15.
Okay, sorry. The session was interesting, so we continued. Yeah.
So we'll have again at 4 o'clock. We'll join.
Yeah, thank you.
Thank you.
This meeting is being recorded.
Hello, sir.
Yeah.
So I have the three datas. One is the result and the time of inspection and the person who did the test.
Okay.
In this data, two persons performing the test, different timing they have performed the test. I would like to put a time series plot.
I want to put the time series.
Yeah.
You have to just use the result.
Okay. So I have to go by groups, right? Or multiple with groups?
You have groups. You can go for it.
Okay. So I need a result in the series.
Yes.
Grouping is
Tech.
tech. Not coming.
Category. If you have cursor in category.
Yeah.
Click OK.
So any else? Can I get the for this timing in the X plot?
No, you cannot get that. You can only do based on this.
Okay.
So you have only two people, huh?
Only two people. Yeah.
Okay. What is this result?
So results are the outcome of the each shift.
Okay.
They are measuring some samples, different samples.
Okay. What is that value? It is height or weight or something like that.
It's a height.
Height. Okay. So it should be within certain limits or something like that.
Yeah, so limits are there. So results are within the limit. So what we like to know is which operator performs gives the different readings.
Then which operator gives
Different readings. Like is there any
what
output
variation?
and reading? Yeah, variation, more variation in the results.
Then you can go for box plot.
Okay.
The box plot. Box.
Oops.
Result.
Okay.
So Kalai has more variations
Yeah.
when compared to Jazz. And you can, when you keep your cursor inside and there is no outliers,
No outliers. Yeah.
you put it as a one box plot, maybe you can check if there is any outliers or not. Both as a combination. Now we are doing as a group, right?
Yes. I'll put it as a single. Okay.
Result. Delete it.
Yeah.
So there is no outliers. Showing starts from 13 to 18.
Yeah.
Height is from 13 to 18. So as far as this, the variation is very high in Kalai. But what is the expected result? Where do you want the range to be?
It is not about the, so which technician, if we found any abnormal result, is it this abnormal result coming from the same technician, or it is coming from, it is happening in the any one specific shift? That we would like to identify.
Is it from the same technician or different technician?
Is it any time frame because of the production variation it was coming, or it is related to the person who did the test lead to the different results?
Okay. But can you show me the data again?
Yeah.
Minimize.
So
You have maximum, you have mentioned the specific time, right? What you
yes.
can do is you can create a category for that. Okay.
Okay.
You can create a category for that. For example, or 453 timings, you can create a category for that. 455, you can create a category for that. And 455.31, you can create a category for that. So you can let us mention that as A, B, and C. Then you
Okay.
can see. Okay.
Instead of technician, I put as a time.
Time.
Is it right?
Yes. So it seems the variation is less at
More high.
455,
Yeah.
right?
Yes.
The variation is less at 455 when compared to 455.31 and 453.36. Highest is at 453.36. Again, if you just take that 453.36 and if you put it in a separate thing and analyze it further, you can identify is it because of Kalei or just.
Okay.
That data you can again go to the next level, drill down approach.
So only taking the 453 and again we can drill down the data. Is it right?
Yes.
Like Excel, can we apply filters here?
Yeah. You can split the sheet, no?
Okay. But here every sheets are coming as a minimize in the separate window. That is a constraint. In 19, it is comes as a continuous sheet.
Yeah. So there it's
Once I
totally
minimize,
changed.
I can.
19 and
I
20,
got,
it is totally changed. Everything is
yeah. I have to look for which one is the graph, which one is the Excel.
everything comes the same navigator. We don't have
Yeah.
that window. You can just copy and paste it in the next
Data. Okay.
79, 80, and 81.
Even I put dot plot also, I can able to understand, right?
Yes. But this will be more.
Easy.
You try. Whatever you want to try. Time series may not be the right tool for this.
Okay.
Box plot. Go for result 1 and C80.
81. Yeah.
So it's color.
Correct.
So if you want to specifically do like that, you have to drill down like that.
Okay.
And we can work out an example for line plot. Hope you remember the example we did here. Strength, centering time, and one more factor. Metal type.
Yes.
Can you say what type of data you can use for this line plot? 1y, 2x's.
1y2x.
Just go to that.
The temperature speed we can utilize the same, right?
Just go to that data.
Temperature.
Just look at that data.
Data.
Strength.
Okay. These three, right?
Yeah, centering time.
Against the plant length, yeah.
So for the same metal type 3 times. So you're using the same centering time that for all the 3 metal types, 1, 2, and 3. And you're using a centering time, a different centering time for metals, again all the three metals. Then you are using 200 for all the three metal types. So like that, there should be a patterned data in your case. You have different temperatures, no? So you
Yes,
should
yes.
have 3 fixed or 4 fixed combinations. So that is what I'm asking.
Okay.
Just change the data so that you can have some fixed.
So if you put 3 different speeds. Should I put so 2 constant, 1 variable. Am I right?
Yeah. 1 discrete. So which is the Y here? Y is diameter. Huh?
Yes.
Response is diameter based on speed
Yes.
and
Speed and pressure.
okay.
We'll copy that. So dia is I put 10, 11. So I will take a graph on line plot. Okay.
What you should select?
So dia is the graphical variable. And pressure. So variables I have to give pressure and the speed or
You have another field, no? Categorical variable. There you mention. The data.
it's not correct. So I have to change the series.
You are diameter.
I have to bring the I'll change the exploit.
So what is your
So dia will change. I have to identify which is the optimum dia.
okay? So
I have
deciding factors. What are the predictors? The pressure and speed predicts diameter, right?
yes.
What you have mentioned is you have changed it. You have mentioned pressure in that place. Go back to that data entry. Here,
So graph variable is a dia.
mention y here. Y is your dependent variable, which is dependent on what? Diameter is dependent on pressure and speed, right? So whatever you have mentioned,
Speed. Yes.
some problem with the data that you have given as an input. Let me look at the data.
Okay. I have 3 different speeds, 3 different pressure.
Okay. It show some variations in the diameter. Show some variations in the diameter. I think it's repeatable values. That's the reason for getting. Let's change it. Without any repetitions, give it. You can give it as 9.5 or 9.2 like that.
Okay.
Without any repetitions.
Can I change the pressure?
No, that should be standard. That should be standard. Pressure and speed should be standard.
Yes.
Only at certain levels. But diameter changes according to that. No? So that will change.
Yes.
Only diameter will change here. All these will be standard. Okay.
Yes.
So now, okay, we'll see that.
Can I go multiple wise?
No, not multiple. One by. You have only one output, not two outputs.
Okay.
Now change graph variable to diameter.
And X grouping is pressure.
Pressure.
This is a grouping is speed or
Yeah, speed only. Okay, that's right. You go ahead. Click OK. So now you can see blue color is 200 speed, red color is 300
300.
and 400 speed. So you have more diameter is better at 400 speed. That is one indication. And when the pressure is at 60. Okay. So a combination of pressure 60 and your speed 400, you get better diameter. You understand? High diameter.
Yeah.
So that is a combination that you need to work out.
Okay. Only mean is reported here.
We are plotting mean.
Yeah. Only average is reported for the 60 and 400 combination.
So the best combination is 460. You're going to use a speed of 400 and a pressure of 60, then your diameter will be so much. Okay.
Yeah.
So line plot is used when there are two x's and you want to predict it.
Okay. Got it. So, and we are using for the pass fail data. This is the pass fail count data. We are using this against appraiser and standard.
So,
Same set of samples given to the appraiser and standard, then the results will be compared. It's like a pass fail only.
pass fail. Do you have the data now?
So this, yes, this test is called as a visual inspection. Same samples measured by both operator.
Okay.
So we have the
Attribute type, yes.
30 samples. Results between the two different people.
Okay. We can go for that. We can do that. Now.
Yeah.
You have a standard here, or it is only within BIM? You don't have a standard here, right?
It is a standard sample that measured by two operator. That's all. That
Okay.
reference standard is existing technician.
Oh.
So for pass file, I'll put 1 or 2 or just pass.
No, it cannot be only pass, no? You have to just give it.
We have to. Pass means the value is 1, fail means 2, like this. And
Okay, then you give 1 or 2. Anything is fine.
yeah.
1, 2. Only 2 columns are
Yeah.
there.
So I'll add another operator. The same results.
So here Kalai is a reference. So just Jazz is here to be qualified.
I'll change only 2 results.
What is the, where is one more column? The sample number.
Sample number.
That should be there.
So I have to go for the gauge under, right?
Attribute agreement analysis. So which column should be selected?
So rating is a visual.
Pass failure. Pass fail visual. Number.
C64. And samples.
Sample easy.
Delete it, then you.
So appraiser, we don't have appraiser. Only 2 comparison is there.
OPS. Delete this reference value. So it's 90%.
90%.
So it is
So out
okay.
of 20 inspected, 18 is matched, 90%.
90%. So beyond 90% is acceptable, right?
Yes.
You are mostly meeting your requirements. There should be a mild improvement, minor changes that you need to work out here so that you can bring out the results more than 90%. Maybe methodology, if you change, you can bring it more than 90%.
Okay. So same completion. Okay. So this is the, what kind of plot it is? It is
Which one?
this plot.
Confidence interval only. It was mentioned here.
Yeah. Okay.
CI.
With multiple groups. Okay.
So CI is generally your value will occur within this interval.
Okay.
95% confident it will be occurring between these two values.
Okay.
Have you used Pareto chart, Pareto analysis?
We have came across, but not much. Maybe I'll try.
Actually, we use for complaint trending. Mostly operation team, they use Pareto, but we don't use actually. We take from the graph from them. Maybe you can try one sample Pareto.
Yeah, so I'll show it here. Then you can see whether you have any data related to that.
Yeah.
So same thing, same Minitab. So Danamohan.
Yeah, I shall.
Minitab. Okay, go to start. Quality tools. Pareto chart. Defects or attribute data in select loss. FLAWS loss. Double click. Okay. Click OK. That's all.
Just okay.
Before interpreting this, just look at the data. Loss. Look at that column. Minimize it. Session loss worksheet. This is Pareto chart. Open that worksheet.
Okay.
Just minimize. Just scroll it. So it should be equal to something. FLAWS loss.
Yeah.
This is the type of reject. Okay. Everything rejects. This is the type of reject. What you are generally identifying from Pareto analysis is what is the 80% of your problems are caused by some 20% of the causes. So, what is the most common issue that we face is we don't give importance to the most important problem. We give importance to less important problems. So, Pareto analysis helps in identifying the 20% which affects 80% of your defects. So, if you identify that and correct it, the percentage of improvement that you're going to get is 80%. Now, just show the picture. Pareto. If you look at this, how you have to read this Pareto is, you can see the percentage on one side, right? Z axis. Alternate axis,
Yes.
see the percentage. There, can you see 80? You go horizontally from 80. 80%. From 80%, when you go horizontally, Okay, it joins somewhere it joins a curve. Wherever it touches the curve, you have to draw a vertical line.
Okay.
Curve. See 80.
Right.
From 8. Yes. So now, which are the important causes? Peel and scratch are the most important type of rejects that you get. If you focus on this peel and scratch, 80% of your defects will come down. So that is what it indicates. Okay. So you have any data related to this?
Yes, Mohan, we can put a complaint trend na that.
Yes.
You take any complaint, recent data we taken, right?
So these are the categories. So these are the categories and these are the complaints.
These are the categories and these are the complaints. Okay.
So for the
Go to start.
quality tools and part C48. So input only defect or?
Yeah, defects, and then frequencies, you select the number of
complaints. Yeah.
The most
Put a
common.
line, Mohan. 80% put a line in that.
So the first one is the major category.
So what is the first one? Chemical,
Physical biological defects.
So that's the most common.
Yeah.
Then you have
That is
damage.
covered.
See, what you can do is when you have more number of causes like this, you can categorize according to cause and effect diagram. To identify which is high in that cause and effect diagram you can do, and then you can do a Pareto analysis. Okay. That will reduce the number of bars that you have, so you can be much more focused. So it shows the first 5: chemical damage, loose contamination, assembling defects, and biological contamination as the most important causes. If you focus on these causes initially and resolve it, you can reduce your problems to 80%. Okay.
Yes.
The what we generally say it is 80-20 rule. Pareto analysis is called 80-20 rule. Okay, fine. Then have you used control charts? Control charts.
Control charts.
So these are something that is you can think about using. You can go to stat, control charts. You can select variable charts for individuals.
Okay, XBAR. Okay.
Variable chart for individuals. IMR chart. Click on that. Select sales. Okay. So it says whether your process is under control or not. I think this is one of the most important tools. You must be using it. So whether it is between upper control limit or lower control limit. So
Here
here's
is control chart, yeah, with lower higher specification. Actually, we do it in the Excel manually.
no, that is not specification here. It is control limit. Okay.
Okay.
It's control limit. It is not specification limit. Specification limit is the what your target. Control limit is below that. If your process is within the control limit, there is no chance of you going beyond your specification limit.
Okay. Yeah.
So here it goes beyond the upper control limit and also below the lower control limit. So in case of sales, is it good or bad? Which is good, which is bad?
Upper is good.
On the upper control limit, it is good. It goes below the lower control limit, it is bad. Do you want to try this for any of your data?
Yeah.
Which data?
What is MR chart actually?
See, there are 7 types of charts. Okay. This is one chart. MR means moving.
Okay.
Moving range.
Yes.
Okay.
The expansion is individual moving range chart. See, all these are every tool that I'm explaining, we have to learn it detailed. Okay, I'm just showing you everything in Minitab. But there are sessions to just learn everything, all these. These are all called 7 QZ tools. Scatter plot, Pareto chart, control chart, flow chart. So all these we histogram. All these together we say it as 7. Oh, you got it.
This is one of the results I have taken for the 30 samples.
Your existing data.
Yeah.
Okay. So your process is under control. It's
So we
not,
have to see here how to interpret this.
what is this value, height or diameter?
Yes, height.
Height. The height measurement is what you have it as individual value. The individual heights is plotted in the top.
First, okay. Okay.
The lower one is range. What do you mean by range? Highest minus lowest. Moving ranges, it is calculating the range of adjacent two numbers. And that is what is plotted here in the lower graph. Moving ranges, range that is calculated between two adjacent numbers.
Okay.
So if you look at the data, you can see the range. There is your data. First one is something around 16.5, then 12.5. What's the difference? 3.5. So that is what is there here.
Oh, so different. So
Highest minus lowest.
okay.
This and two numbers, highest minus lowest is plotted here. And actual data is plotted in the top.
Top. Okay.
So this gives you an indication whether your process is under control or not. If this says your process is under control, we will not make any changes and you can just move to another process. So what we do with control chart is day to day. For all the processes, if you're going to put a control chart, you can check which process is going out of control, take actions only for that. Okay. For example, it could be speed, or it could be pressure, or it could be temperature. If you just take only the pressure data and put a chart, then it can show you whether it is under control or only the diameter like that. Okay.
Got it.
What about X chart, X bar chart, P bar chart, something?
No, that is there, but we have to understand that only when I explain you completely about all the control charts is a separate thing. Okay. So yeah, I'm just giving you an idea about what is a control chart. Okay. So there are 7 types of charts. For that, you need to understand how to select a chart, how to calculate upper control limit, lower control limit. All those things are there, and each and every chart has a different criteria.
Mr. Kanagraj, maybe later session, maybe I will ask Ganamogan to get a contact for the quotation for the sound QC tools. Maybe in that session, maybe you can have one more session. Maybe you can organize for us, maybe to brief. Maybe that will be useful for us. Maybe.
That's the reason I'm just giving you, because in our thing, this Pareto or cause and effect diagram, control chart, all these are not part of this training. So I'm just giving an idea.
No problem. We'll keep in touch with you for another session program, Sound QC tools. Maybe we'll get a quote from you, then we can proceed on that. Yeah, later. Sure. Morgan, please note down Morgan that one.
Sure, Morgan.
Thanks, Kanara. Yeah.
Okay. Now you can go to.
Maybe Kanara, maybe if you have a list of topic, maybe you can cover. If you send, that will be better. Maybe we'll choose multiple program maybe in the part. Maybe if you share a list of training, maybe you are able to complete for online. If you send a list to me, then it will be better for to decide furthermore, not only QC tool, other program also. Can you please send to me that list of trainings related?
Sure, sir, I'll do that. So basically what we are supposed to do is this Minitab is going to give whatever output that you expect. But you should do that situation, what tool should be used. So that
we should know the basics to use which tool to be used, right? So
see, when you take, you have directly asked for ANOVA, but before ANOVA, you should know about, if you just go to stat, there are a lot of tests will be there. Go to stat, go to basic statistics. See, before ANOVA, you should know about all these tests. 1 sample Z test, T test, 2 sample T test, parity T test. All these are primitive tests. Okay, before thinking about ANOVA, you should do all these tests and check whether there is any difference or not. ANOVA is more than 2 samples. For 1 sample, how to do? For 2 samples, how to do? So, I'm just taking whatever that you have asked.
Yeah, sure. No, we are not say anything on that. We just want to understand Minitab how to use the tool. Which tool we have to use? We have different program. That way only we request maybe the list. If you give the list, maybe we can choose. We can club together for the another program or maybe multiple programs. Yeah.
Sure. So then there is anything else, I'll just give you an idea. Go to graph.
So any other clarification needed, Pratap, Dhanamogan, Krasan, any other graph or any other clarifications? Because almost 5 now.
Yes, sir.
No, sir. We already discussed the record charts already.
Kanagra, in case of any small clarification in future, maybe it will be possible to give some clarifications, maybe in case of any feature. Maybe we will not disturb frequently, maybe.
Not at all an issue. We can absolutely clarify it. So because you will be getting more clarifications only when you start doing more and more.
Correct.
So you can absolutely contact me. I can allocate a time. I can connect.
Yeah, sure. Thank you very much. Yeah. We will not disturb you. Maybe in ad hoc basis. Maybe sometime if you are not have stuck anywhere else, then we can contact you on that. Yeah.
It's a pleasure for me to help you on that.
Thank you very much. Yeah.
So I can do that. So and then finally, how to save? Let me finish with that. You can just minimize it.
Yeah.
So go to session. you have all these icons, right? You have an icon named as report pad. You can see it here. It looks like a book.
Report pad, right?
Click on that. Okay. So you need to go to this. Okay. And you click on the session. Now you have all the details that you have done so far. Okay. So what you are supposed to do is click on the descriptive statistics. Right click on that. You can send it to, click send to Microsoft PowerPoint.
Oh, PowerPoint, Morgan.
Anything. If you have Word also, it will go. So you check your Word or PowerPoint. Is it there?
Yes.
Okay. So you can directly export it to PowerPoint and you can make it as a presentation.
Yeah.
And you can save the total project also. So go to File, save project as, and give the name. And you can save it. Specific name you can give it.
Put today's date, Morgan. You can say it's today's date.
So all the worksheets, all the details, whatever graphs, everything you have done so far, it is saved in this. So if you want to directly take it to presentation immediately, as I said to you, you can send it to Microsoft PowerPoint and it will be added to every slide. And finally, you can use it for your presentation. Or if you want to take some printouts and give it to somebody, then you can send it to Word.
Okay.
And give it as a document to them. For reference.
Okay.
Okay, fine.
Just very easy to.
Yeah, so any doubts you can ask, you can give your feedbacks also. How was the training?
I think first of all, thank you very much, Kanagaraj, for accepting this. I also thank Dhanamogan identify excellent trainer, maybe you can say a coach. So really, it's a very good, you are very user-friendly training. It's very easy and you taken away is very user-friendly. It's easy to understand. I think that is why we are more interested to go with further more training with you because we are very happy to attend the session. It's very user-friendly. People can able to understand easily on the part. So thank you very much, Kanagaraj. Actually, you are it's really very simple, your way of teaching methodology on the part. And you are very patient, polite for all our questions and disturbances. So really thank you a lot.
Disturbance.
That shows, that demonstrate your caliber and your scholarship.
So if you have, you can work out any issues that problems that you have, and you can just come back to me with data.
Yeah,
I will be absolutely ready to help you on that.
Yeah. Please send me after that email your list of training program related to you do statistical study analysis and trainings and techniques. We'll choose, then we'll get back to you on the training program. Definitely we'll, this is not the only session, we'll future also we'll keep in touch with you for the trainings.
Thank you.
We also recommended to our operation team, they also interested on training. So if you send the list, I'll share to the other HODs. Maybe you can combine together all the training program.
Sure. I'll do that right now.
Yeah. So thank you very much, Mr. Kanagara. Team, anybody want to give any feedback?
Yes.
Thank you, Kanagaraj. It was very useful session for us. Really, we are able to understand the Minitab. Even though we have the access to Minitab, we cannot able to use the tools correctly. Right now, we get the better clarity on the tools available in the Minitab, and we got the basics also from you. So the basics help so much to use the tools.
Yes.
So thank you for the session.
So I recorded session. So if you have any doubts, you can even refer to that. So that will help you to. I think most of their initial problems can be corrected from that. Even after that, if you have any doubts, you can answer.
So where we can download this recorded session?
How to download the record session? That's what I want to ask. Yeah.
To a mail. I'll send
it. Okay.
You cannot directly download it. I have to download it first.
Okay,
Okay.
okay.
I will send it to you.
Maybe can you
Yeah.
share the slides, Kanagarat, that you presented?
Yes, I'll share it. That's
Yeah,
not a
please. Thank you very much. Have a good day. Thanks a lot. We'll keep in touch
Thank
with
you.
you in
Thank you
future,
so much.
definitely.
Sure. I'll send you the mail and we'll
Yeah.
Thank you, sir.
Thank you.
Thank
Thanks
you.
a
Thank you
lot,
so much,
sir.
Kanagaraj.
Thank you.
Have a good day.
Thank you.